Well, when I started, they hired me because the project was really behind. We had started ramping up for what was going to become the National Trends Network. So NADP, which started as this NC 141, the small project in North Carolina, and kind of grew, was going to kind of hit the big time. I think as people were probably anticipating emissions reductions from power plants, and there was concern about the whole acid rain phenomena and stuff like that. So, it really just grew with technology. I mean, I had a DARPANet address early on. The interesting kind of paradox for me, and this is something I think the project still faces, is that you're trying to do an effective job of monitoring the environment, create a chemical climatology for North America, and in some places you stay stuck where you are. I mean, our field equipment was then and is now pretty much post-Korean War, early Vietnam War technology in terms of electronics and power supplies and motor builds and stuff like that. So the paradox is that you're trying not to make any changes because you have a trends monitoring program, and things literally become unavailable that are at the core of your monitoring task in terms of field instruments. It's just like the rest of life. We had to learn how to use, first email, and we got people who could program websites. So a user was very interested in their data. You need to lead them to where their data was on a website. And then we got pictures, so that people could actually click onto a place on the website, get to their site, and even show their peers the surroundings, and then lead them through some data. And literally, when I got here, our most highly developed maps were very simple, like line drawings with pixeled resolution screens from old CRTs and stuff like that. And we were running major parts of the program on an old VAX that would today, I mean, there's probably more power in the phone I have than in the mainframe that the Water Survey had then. And the base, I guess it's important for me to state pretty early on that the base that Dick Simonin and Gary Stensland and Van Bowersox had put together, and people like Kathy Douglas and Randy had been working on doing the programming, was there for me. So it's not like I had to step in and create this as a new thing. I had a lot of good mentors. So, in the beginning, God created the bucket and the lid, and thou shalt take off the bucket and mightily hammer the lid upon the bucket and send it to the lab in its totality. And the bucket's 3.5 gallons a bucket. I've lost the conversion now, but that's like 15 pounds of water. After thinking through this a lot, and Van and I sat and we poured from this device to that device and thought about transfer and thought about chemical integrity, really. I mean, that's the first thing. Until we were pouring the samples into the 1-liter bottles that they're currently used now, and then that amount of water that was left could either be used at the site for a research purpose, and we had kind of a way to register and help people and make sure people understood about it, and then they would just ship us in 1 liter a sample, which is plenty for the analysts. You think about some of these that are more related to extraordinary events like St. Helens or Chernobyl or 3 Mile Island or whatever, but a lot of the time, at least for me, was spent in the trenches with special projects that were related to really understanding how much we understood or knew about our samples from a real basic level. So running projects where USGS and the Water Survey cooperated with a co-located sampler program, where we would go into a site that had been operational for several years and establish another duplicate set of equipment so we could get an idea, looking at those 2 different measurements from 2 different collectors and 2 different rain gauges, what the variability of our own network was.